What's going on, everyone, and welcome to episode number 7 of Everyday Python Projects. In today's episode, if you couldn't get it from my really crappy intro, we're going to do a little bit of web scraping using Beautiful Soup. The video is going to be split up into a few different sub-projects so that you can get started with web scraping. First, we're going to learn how we can pull paragraphs off of a web page. Second, we're going to learn how we can quickly and efficiently extract all of the links on a web page. Third, we're going to learn how we can loop through different pages on a website and pull specific information that we're looking for. Fourth, we're going to learn how we can pull tables from a web page without having to format them ourselves. Let's get into it. We'll have to import a few libraries to get this started, so let's use the following. So we have requests, and from BS4, import Beautiful Soup. As always, if you don't have these libraries installed, you can use pip, which is Python's package manager, to install them by typing them into the command line or the terminal for Mac users like so. Pip install BS4, and I already have it installed, which is why this says requirement already satisfied. Otherwise, it would install it right here. So there's usually 3 parts to every web scrape I conduct. You have the URL, the HTML, and the soup that parses through the HTML. For this example, we'll look at my blog post on how to meditate, as I am a strong practitioner in meditation for emotional regulation and improved cognitive functioning. In case you're interested in reading about this, check out the links in the description below. So first, let's create our URL variable. So this is just a link to my post. Then we'll write HTML text is equal to requests.get URL.text, and soup is going to be equal to Beautiful Soup HTML text, and we'll be using HTML parser. So the URL is self-explanatory, it's just a link to the website. HTML text retrieves the full HTML from the URL. In case you want to see what this looks like, it's a big mess. Let's run this first. Which is all this mess right here. Definitely not something that's easy to read. And soup parses through the HTML using Beautiful Soup's HTML parser. Now, in case there are issues with sending a request to a URL, certain URLs don't allow web scraping, so we want to see if our request was able to go through successfully. I'm going to write this print statement to let me know if my request actually went through. So this is going to give us a response code, and this is just passing in request.get URL, same thing we had up here, just without the text method. A response code of 200 means that the page was successfully scraped, and we got it here. Let's just double check. Yep, response code of 200. With Beautiful Soup, it makes it really easy to look for particular tags, such as a paragraph tag, so we can type in the letter P, like so. And this is far quicker than performing a regex to search for the actual tags and everything that lies in between the opening and closing tags, because right here we're able to get the last paragraph tag on my blog post in a very, very quick and easy way. If you want all of the paragraph tags, you simply need to write find all instead of find. And here are all of the paragraphs within this post. Obviously, this isn't the neatest formatting, so we can use a little cleanup to make this more readable. First, let's create an empty list called myList. Then we'll create a for loop where we'll loop through each of the paragraph tags and extract only the text. Each paragraph tag will then be appended to myList. So for thing in soup.findAll, and remember we're looking for paragraphs, so we're using the P tag. mylist.append thing.text.strip. So thing.text retrieves just the text from the paragraph tag, and the strip method removes the leading and trailing spaces from the text to make it easier to read. So once we execute this, let's look at a couple paragraphs within my list. So here we're looking at the 300th element. The neat thing about meditation is that you can practice it anywhere, so I don't worry about falling behind. And let's look at one more. I continued to make some progress and felt in the zone for longer periods of time. Unfortunately, things changed when I moved to New York City for employment. Were I to print out the entire thing, this, although there's a ton of stuff here, is easier to read than what we had earlier where it was a big jumbled mess. So what about getting all of the links on the page? Once again, Beautiful Soup makes this super easy for us to do. We just have to make a couple of changes to our code right here, and we'll be able to get all of the links. So first we're going to change the P to an A and write href equals true. And let's change this to links to make it a little easier to understand. And then we're going to write mylist.append links href. So we set href equal to true to make sure that we're retrieving an actual link, as href is a tag for links in HTML. And then to extract just the link, we're looking for href here in each of the links that we're able to pull. So this time, if we look at my list, we can see these are all of the different links that are in this post. See, blog, tech, fitness, and some of the sources that I was able to pull from, and we were able to get this really neatly and easily. Obviously, there's a little bit of extra code or extra items in here, but that's a small price to pay considering we got all of this within basically 2 lines of code. If we decided not to look for href right here and instead pull all of the information, it would look something like this. There's too much information here for us to read this quickly and then use it later on. We don't want to clean these links up twice if we can do it correctly the first time. I see you haven't hit that like button yet. Smash it now to make me the greatest Pythonista in history, please. Our next task is to modify our existing code so that we can loop through the blog pages and pull the information that we need. This is pretty simple. We just need to introduce a for loop and modify our URL to go from one page to the next. So we can delete all of this, write mylist equals an empty list up here, then for x in range 1 to 3, indent all of this, and copy our new URL. For your range, make sure that whatever the number of pages you're looking for, in this case 2 pages, your upper bound is 1 more than the total number of pages. My blog post has 2 pages in total. If there were 15 pages, this would be a 16 right here. Why is that? Well, the range object in Python goes from its lower bound up to, but not including, its upper bound. In this case, the structure of the URL is such that the page number appears after blog, like so. But if the structure is different, make sure to format your URL appropriately so that you can just pass in the page number. Then we use the same idea as before. We need to find a specific HTML tag on the page that pertains to what we're looking for. So I'm in Chrome right now, and to identify the name of the element we need, we're going to right-click the information we want, and then click Inspect or Inspect Element. We can see right here, we're looking for an h3 tag with the class name elementor-post__title. So let's copy this class right here, and we're going to write the following. For things in soup.findAll, this time we're looking for an h3, and then this part is new. I have curly brackets, class, and we're going to copy and paste the class ID. Then we're going to write mylist.append things.text.strip. So once we run this, we can check mylist to see if we have all the titles on both pages. So here we can see all of the titles in my list. Let's just check quickly how long it is. Okay, there are 10 items here. And let's see, on this page, I have 1, 2, 3, 4, 5, 6. So it must have searched the second page as well. 7, 8, 9, 10. Okay, it was able to get all 10 posts from my blog. In case you wanted to see this whole text.strip thing in action, here's what happens if we just write things in the console. So you get this entire tag right here. Now if we write things.text, you can see we were able to extract the title. However, there are all these spaces before and after. So now if we write things.text.strip, we get a very neat title without any of these leading or trailing spaces. So this is fairly scalable. However, there's one precaution that you have to take if you're doing this against many pages on one website. There are certain rules to web scraping that programmers need to adhere to. Usually this is found in a website's robots.txt file. However, there's some common courtesy as well that we can include. You don't want to attack a website with multiple requests a second for an extended period of time because it can throttle the website's server. If you do this repeatedly, that means your IP address can be blocked, which means you can't access the website anymore. So please be courteous when you're going about web scraping. In order to not throttle a website server, we can write the following bit of code to pause a few seconds every 10 pages. So we can write print x if x mod 10 is equal to 0. Basically, this is saying if whatever page you're on is divisible by 10, then write print pause on page bracket, and we'll pass in x and time.sleep 3. Don't forget to import time as well, otherwise this won't work. Now the script will pause for 3 seconds every 10 pages, which gives the server some time to breathe. If you want to adjust the number of pages to search before resting, just change this right here. So if we wanted to look at it every 5 pages, or if we wanted to rest every 5 pages, we would just change it here like so. Finally, we're going to learn how to extract tables from a web page without having to manually parse through the HTML ourselves. So the first thing we can do is just delete all of this, and we're going to import pandas. Then we're going to write our standard 3 lines of code for web scraping, as well as our print statement to see if we were able to access the page. We're going to use a Wikipedia article for Los Angeles because it has a ton of tables for us to parse through. Next, let's find all of the tables within the soup. So we can write my table is equal to soup.findAll table. And if we execute this in the console, we can see it's kind of sort of a set of tables. You know, we have all of these li tags right here. So there's like a loose structure to it, but it still looks like a jumbled mess. To give it some structure, we'll use pandas read HTML to parse through the tables and return it to us in a neat format. So let's write df is equal to pd.read HTML, and we'll write string my table. For this to work, we have to convert my table into a string. Otherwise, pandas won't be able to read the data properly. So df is going to be a list of individual data frames that we can access. And first we can see how long it is. Okay, so we have 45 tables here. Let's check one of them out. So here we see that this is a table of articles related to Los Angeles, and it's neatly structured for us. There are some empty columns here and there, but honestly, that's a small price to pay to get all the tables in this article almost instantly. If I were to zoom out of this, it might be a little easier to see. All right, so we can see like so, we have articles related to Los Angeles and a few empty columns right here. As for the empty columns, we can always just drop them from our data frame of choice, so it's not really a big deal. Now, if you want to look for a specific table, you can find it by calling its class in soup.findAll. So here we can change this from soup.findAll table by including class, and we need to find the class for this article. Now, I already have it loaded up right here. It's this table, and were I to find this, I can see that this is the table it relates to, and its class is wiki table. So now if we execute this, we see that the first table is the table that we're looking for. Like so. Let's be honest, sometimes this can be kind of hard to find if many tables share the same class element, but a little trial and error will get you pretty far. There you have it. You just learned 4 different ways to pull data from the web with web scraping using Beautiful Soup. Thanks for making it this far into the video. If you enjoyed it, please drop a like and comment below, and make sure to hit that subscribe button. I'll see you in the next one.